Later, I think, Liam, just for the sake of time, I want to just deal with the velocity stuff. Today is called the Quotient Rule. This is one of the three proofs that are possible on your test. Okay, the three proofs that are possible on your test would be the Quotient Rule, which is today, the Product Rule, which is the one that Reed did, and the regular, just plain rule. And there's the plain, the regular one. The chain rule we will not be proving. Okay, so the proofs that are possible erase this will be x to the n equals nx to the n minus 1, and then f prime of x equals g prime of x, h of x, plus h prime of x, g of x, and then today's lesson. Okay, those are three things. Those are the three things that are possible. Okay, so this is today's lesson here. Start with that. So as far as the quotient rule, we're going to say if f of x, can I go here please? If f of x and g of x are differentiable.
You always have to state that.
Yes.
Is there times where they're not?
Yes.
Like if it would equal 0?
Yes. If h of x then equals f of x over g of x, what is h prime of x? If you'll notice today that our warm-up was with a fraction question and it was a mess. Okay, this is hopefully going to make the fraction questions a little bit easier. Oh yes you can, and you will every single time probably. That's what tomorrow's the messiness. That's when your assignment is all a mess like that too.
Is it really that bad? I was looking at it, I was like, oh, you could probably do that, but I haven't attempted them.
It'll be okay. It'll be fine. Okay. So again, what is h prime of x? What today is a rule that you can do to speed up fractional questions. Now, you don't have to do this. If you're like my friend in high school who hated learning extra things that repeat, he used product rule for this. And as you saw in your warm-up, we solved a fraction question with product rule, and it was fine, but it was messy. Like there was a lot of stuff we had to do to bring it all together. This brings everything together in one step for you. Okay. Here we go. Here's my proof. We're going to say h of x equals f of x times g of x to the negative 1, which is what we've done already. Okay, any suggestions on what you would do now to take the derivative here? If I take the derivative of h prime of x, take the derivative of h prime of x, what do we do then? What is the right-hand side going to turn into? Well, let's just think for a second. Let's just think we're going to use product rule here, right? The two things times together. What's the product rule going to be? Yeah, so it's going to be f of x. Now we can already do g prime of x. This is going to be times negative 1 times g of x to the negative 2, negative 2. Times g prime of x. Okay. So what we did was use the chain rule there on the g of x. Okay.
Oh, it's chain rule.
We use chain rule on g of x. Then we're going to say plus. I'm going to move this. Darn it. Plus.
So that was chain rule on g of x.
Chain rule on g of x. Plus f prime of x times g of x to the negative 1. Okay, we lost anybody yet? So what we just did was we just used chain rule there. That's what we did. Okay, just like we did before. We're trying to do a general neat case for this, so we don't have to do all the messiness. Then I'm going to rewrite it as a fraction.
Okay.
Yeah.
Pretty sure that that goes.
Sorry?
G prime is x.
Oh. Here I go. That's true, it wouldn't. Thank you. Okay, so I'm going to rewrite that as a fraction. I think I'm going to go up here. I'm going to go up here, I think, up top. So this is going to equal, I'm going to write this backwards, f prime of x all over g of x minus f of x times g prime of x all over g of x squared. So all I do is I rewrote that in fractional form. So f prime of x divided by g of x minus f of x times g of x, g prime of x.
Oh, the negative. That's why.
The negative 1 turns subtracted.
Okay.
Okay, can somebody finish this off and tell me what my product quotient rule is going to be? How do I finish this off? If I subtract those, what do I need? So this is just going to equal then h prime of x is going to be f prime of x times g of x minus f of x g prime of x all over g of x squared. This is our quotient rule right there.
Is this one of the ones we have to memorize?
Yeah. Well, that isn't even much of proof, right? Like that's fairly nice.
That little dot after g prime of x, is that just times?
Yes, that's multiply, yeah. Okay, so what happens, the order does matter for this. Whatever you're dividing by is the one that gets subtracted when you take the derivative of it. Does that make sense? Whichever one you're dividing by, that's what you're subtracting when you take the derivative of it.
There's a little bit of product rule.
Yes, there is, definitely. And that's why we need to do this one last, because it's product and chain together. That's how they get the quotient. And that should make sense because when you divide something, it's like you're multiplying, right? It's like times the reciprocal, right? That's how the dividing works. Okay, that is something useful to know. So the derivative of the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator divided by the numerator squared.
Right.
Oh, yeah.
It is something useful to you.
That should be a
Here we go. We're going to do 100 examples. What I want to do is 100 examples. We're not going to time the 100 examples. So I'm going to do probably 3 examples. I'm going to start with a nice one, and then we'll work at the ones that go on less nice. Example 1. Let's do if f of x equals 3x minus 2 over x plus 1, find f prime of x using, it says f prime of x, it's supposed to say f prime of x, using the quotient rule.
On the test where you specify what you have.
One question I will say using the quotient rule. Okay, the force you'd use it for one question. Every other question you're going to have to. Actually, I'm probably, if you don't want to use the quotient rule, you're just going to take it 10 times longer. Okay, so I will not force you to go before you slow. What I'm going to do now is ask, where do we end up with here? Graham. We're going to set the general equation for quotient rule is going to be something like this. H prime of x. I won't do that. Is going to be f prime of x times g of x minus f of x times g prime of x all over g of x squared.
Should we put the,
Okay, so the reason I'm doing this here is because I'm writing this out slowly. Actually, I'm finally going to change this to make it a little more nicer here. I'll just call this h of x if you don't mind. Sorry if you already written that in your notes. Okay, just because we're going to need that for this first one, and then write it everything. Okay. So Graham, in this case, what is f of x equal for this equation? 3x minus 2. What is f prime of x then?
3.
Okay. G of x, Michael, is going to be what? Good. G prime of x is going to be 1. All right, Robert. I want you to be brave and to sub all these things into the equation for me, please. Go ahead.
Okay, f prime of x is 3.
Yeah.
And g of x is x plus 1.
Yeah.
Minus, brackets, x plus, or 3x minus 2.
Yeah.
Times 1.
Yeah.
All over x plus 1 squared.
And that's all there is. We gotta neaten it up, obviously. Why is this easier? Well, because there's none of that common denominator stuff that you need, right? That's the difference in even using the product rule. Gives you that common denominator stuff that you get. I'll neaten this up for you quickly. This turns to be 3x plus 3 minus 3x, sorry, minus 3x plus 2, is that right? For x plus 1 squared, which is h prime of x is 5 over x plus 1 squared. You know, that was very easy, okay, using quotient rule, okay? With product rule, you would have to, you know what I mean, multiply things and common denominators and everything else. Okay? I'm going to do one that's a little bit more intensive right now, okay, and then I'll probably either go back to working homework questions from last night or stop after that, okay?
So you don't want us to expand the denominator?
No, definitely not, okay? The only time you expand is when you're adding or subtracting. Okay? That's the only time you use expand.
The top is the focus too.
Sorry?
The top is right.
Oh, I think it's 5, because like negative times negative, I think.
It is 5.
Yeah, it's fine.
We're at negative, because we're at negative 3x and negative 2, should be a plus. Okay, I want you guys to try example 2.
Minus 2.
Yeah, but you're subtracting. Okay.
Why is it period minus 2? Okay. Oh.
Okay, let's pick something fun.
The squared.
Well, gx squared, so this is g of x is x plus 1. That's x plus 1 squared.
Like in the equation. Oh, okay.
Example 2, and please put a star beside this. So this is the type of question I'll be getting. Okay. It goes into if h of x equals 5x plus 4 all over the square root of x plus 1. Find f each prime of x. Okay, so this is the one that Reed looks at on his assignment. He goes, well, that doesn't look that bad. I can probably do this, right? Yep. This is the one. Okay, so what I want you guys to do, I'm going to put down my marker right now and hit pause. And I want you to try to, this is normally helpful for people to do this f of x and g of x stuff. Okay, so if you need to do that, go ahead. It's not like a waste of time because you won't get mixed up. You can imagine what's going to happen soon. There's going to be chain rule questions, you know, chain rule in the numerator, chain rule in the denominator, right? Stuff like that's going to happen soon enough, okay? So we'll do all your rough work on the side there, that's fine. I'm going to hit pause and I'll come back, and you guys can struggle with this for a minute.